Okay, half-life is really useful. This is actually how people radiocarbon date like things in an archaeology find. The idea is that carbon-14 is in plants. Animals eat those plants, and the carbon-14 then goes into the animals. When the animals die, there's a certain amount of carbon-14 in their body at that time. Over time, carbon-14 decays down, and we can measure the difference, and based on how much has decayed away, we can figure out how long have they been dead. So here's an example. Carbon-14 has a half-life of 5,730 years. So if a fossil has 80% of its carbon-14 left, how old is it? So let's start by making our model. One thing to keep in mind is we're talking about percents here. So what percent do you always start with? 100. So in the beginning, we imagine they start with 100% of their carbon-14. We do e to the, and we don't have a rate, so we're going to put this in first. We also don't have a time yet, and this is our model. So first, this is actually a two-part problem. We're going to first need to plug in what we know to figure out our rate, and then we can go back and figure out how old this fossil is. So again, I'm going to put 100 e to the r, and I'm going to use the fact that it has a half-life after 5,730 years. I'm going to plug 5,730 in for the time, and say after that amount of time, I should be down to 50% of what I started with. Now this will let us solve for r. I'm going to divide by 100 both sides. So this is e to the, and I'll just switch these around because normally the number is before the variable, all equal to 0.5. Now I'm going to do the translation version to solve this. I'm going to rewrite this as a logarithm, and we get to flip sides. Keep the base and flip the sides. So this would be 5730r. r is going to be ln of 0.5 divided by 5730. When I work this out, my rate is about negative 0.00012. It's a very slow percentage. But now we have our full model. That is the r that we should have here. So now let's plug it in. E to the negative 0.00012 t. And we're asking the question, when is 80% left? So now we have everything we need to get our time. Divide by 100 on both sides. And we get 0.8. And I'm going to translate again. This is going to be the ln of 0.8 equals that. So the time is going to be, if we take ln of 0.8 divided by negative 0.00012, and we have to crunch that in our calculator. When you do, you're going to find it's about 1859. So approximately 1800 years to 1900 years ago, this fossil has died.